we're going to talk about quadrilaterals. We're going to talk about different types of quadrilaterals and their properties that are going to be super helpful for you next unit. So pretty much we're taking all this stuff we're learning in Unit 5 and then taking it and applying it in Unit 6. So this is going to really help you for doing well in Unit 6. So make sure, ask questions, getting things clarified, so that way you can take what we do this unit, apply it in Unit 6. Okay? Yes? Yes, so this is Unit 5. This old notes from last year. That's a 5. It should say 5 on your paper. It should say 5 on your paper. The first type of quadrilateral we are going to talk about. What is a quadrilateral? A figure with how many sides? 4. 4-sided figure. Okay. First type is a parallelogram, which is a quadrilateral which both pairs of opposite sides are the parallelogram, the opposite sides are going to be parallel. So that is a known fact. If you're given a parallelogram, you automatically know those opposite sides are parallel. Some theoretic properties about parallelograms that are super important. The opposite sides of parallelograms are parallel, but they are also congruent. So if we look at this diagram and mark it, we know AB is congruent to what side? BC, the one across from it, opposite. And we know AD is congruent to BC. No fact. Opposite sides of parallelograms are congruent. Here. We also know that the opposite angles of parallelograms are also congruent. So A in this diagram would be congruent to what? C. And we know D would be congruent to those opposite angles are congruent. Consecutive angles, so when I say consecutive, I like to think next to. So angles next to each other, side by side. When they're right next to each other. In a parallelogram are supplementary. And supplementary means, again, they add to 180. So just as an example, A and D are right next to each other. They follow the same line. They add to 180. A and B would add to 180 with another set that would add to 180. So two angles that are next to each other. B and C would add to 180. What's another set? D and C would add to 180. Think if they're on the same line, they add to 180 on that same side. Questions over that? The reason why they add to 180, remember, the opposite sides of parallelograms are parallel, so they are same side interior angles. And same side interior angles add to 180. So that's why. If a parallelogram has one right angle, it's going to have 4 right angles. So one of them is 90 degrees. All the other ones are also going to be 90 degrees. Another important property is the diagonals of a parallelogram bisect each other. And the diagonals of a parallelogram bisect each other. It means they cut each other in half. So we have this diagonal here and this diagonal there. That means this piece and this piece are the same, and those two pieces are the same. They cut each other in half. They bisect each other. And one last one. Each diagonal of a parallelogram separates parallelogram into two congruent triangles. Meaning, I'm going to highlight it. This triangle right here, with that diagonal, would be congruent to this triangle right here. So if you draw in a diagonal, those two triangles that are kind of sitting on top of one another are congruent. Yes.
Are we gonna have to use anything from last unit?
Oh yes. And prior units. They're all kind of taking a bunch of stuff we learned and combining it into one
all coming
lovely
back.
big unit.
Sounds awesome.
It is.
It's a lot of fun. What? Alright, so now we're going to take those properties and apply it to parallelograms. We're not going to need a group to do the short period, so we're just going to plow through it together. In example 1, it says quadrilateral LMNP is a parallelogram. We're going to take that information to find the measure of PLM. Well, we look PLM is this angle right here. We want to find that measure. Well, look back at those properties. What do we know about angles in parallelograms?
So it's like those are alternate interiors that are on the side of the square.
That is one, yes, you're right. Alternate interior angles. What else do we know? It's a parallelogram. That's one way. What else do we know?
It's equal to the other side.
It's equal to the other angle across from it. So we know it's also equal to this angle. So if we can figure out the measure of this angle, we easily know the measure of that angle. Well, how can we find the measure of that angle? Add them together. Because these two little angles right here make up the whole thing. So if we just add those measurements together, what do we get? 100 what? 108. So this angle right here is 108 degrees. Okay?
That's easy.
Yeah, not too bad. You were right. We got alternate interior angles. So with that concept, this is 42. That's going to be 42. And this is 66. That's going to be 66. You add them together, you still get 108. So
Lots of ways to solve these
lots of
problems.
ways to solve. Okay. Well, now we want to find LMN. Well, to do that, I'm going to erase these angles that's highlighted. Highlight. We want to find this guy right here, LMN. Okay? Well, we don't know the angle across from LMN. We don't know that angle. But what do we know about the angles next to each other? They equal 180. So if this is 108, what can we do to find that angle? Subtract it from 180. So all we have to do is just do 180 minus 108, and we have that other angle. 72.
What kind of angles are those called? Like, no, I'm confused. What kind of angles are those?
Next to each other,
Yeah.
they're supplementary, because they add to 180.
There's no other name for it.
Same side interior.
Same side interior, so they add to 180. So supplementary too.
Consecutive angles. Well, it used to be consecutive angles supplement. Same side interior.
Questions?
Back in the day.
Hold it.
Let's build some more practice. Alright, why not? We're here. We want to keep tying stuff back from our past and solving it. So now we got these guys. Again, there are some typos. Don't have a little meltdown. Other people have one. You see up here on your papers, when we print these out, sometimes there's a little typo. Yours has a Y there. That's a parallelogram symbol. So a parallelogram symbol is basically a slanted rectangle. So anytime you see that, that represents parallelogram. Like when we had triangles, we drew the triangle and all the stuff like that. Yours has a Y. Just cross out the Y and draw that little symbol I drew over there in the red. All right. So using parallelogram JKLM, there's four sides, so you have it that way. Find the measure of each, or find each measure or value. Okay. Let's go ahead. Let's outline some first stuff. MJK. MJK right there. So we're looking at this angle. I need to figure out what the value of that angle is. Who has an idea of how to figure out that angle? Yes. You. Yes. You do. You look at the opposite angle. So it looks like it's matching up with these two down here. So you were going to say, all right, 30 plus 70 will give me that value. 30 and 70 gives you a hundo. So I know that MJK is 100 degrees. Very hot. All right, there's one. Well, let's talk about this other angle. JKL. Just kidding, I'm laughing. JKL. So we're looking at this one. How do we figure out that? Because I don't have those angles opposite. There's nothing over here on this M part. So I can't add them together. Jake, what do we got? Exactly right, because I know angles that are side by side are consecutive. They are also supplementary, so you're on the right track. I can do 180. He said minus 100 because that was my purple angle. You want to go ahead and write that in there too. If I subtract that out, I will get my other angle, that JKL. What is 180 minus 100? 80. Got it. So I know that JKL, just kidding, I'm laughing, is 80 degrees. A little chilly, but I'll take 80 degrees. This other one. I love it. Love it. I wish he was on my house. All right. KJL. KJL. 30 degrees. Yeah, I can just make up numbers too. It's 40 degrees. I can't just make things up like that. Who's saying 30? And then give me an explanation why, of your ridiculousness. KJL, why is that 30 degrees? Alternate interior angles. I will accept that answer. Remember, we're talking about parallelograms. So we have parallel lines. That is parallel to that. This guy is parallel to this guy over here. So I know they're parallel. What was formed on parallel lines? We have those alternate interior angles. So this angle matches up with this other one down here. This other one down here happens to be 30. So yes, this is 30 degrees. About the 10th what it was this morning. Now this last one is no longer an angle. We are talking about solving for a variable. Shay, you have an idea or just working that rotator cuff? All right, good. Well, how can I solve this A? First off, where's A at? It's one of the sides, right? So, what's something I know about? No, not you. What do I know about sides? All right, you.
They're equal to each other.
Sides are congruent. Opposite sides are congruent. So I'm gonna look. What side's opposite that 3A? What's opposite 3A? 21. So I'm gonna say those are congruent. Not only congruent, they're equal. So I'm gonna set up my equation saying so. So 3A, go on that A, is equal to 21. One stepper, you are correct. Divide by trace, divide by trace. A is equal to 7. C. All right. 7. Found it. Questions on that one? A lot of good stuff. Alternate interior angles, supplementary, opposite angles, congruent, all this good stuff here. No questions? None? Next. This guy, again, there might be a little typo on your paper. Make sure you're fixing that or you understand what it is. But we're using parallelogram NQRM. I wish it was an O, it would have been norm, but whatever. So we got to find those things. There's my picture. All right. W. What is W? You see where it's at. What is that? No, it's W. It's different. It's different. Because it's a W. That's a 12.
No.
That's a W.
What is W equal to?
I didn't say that. I said, where is W? What piece is W? It's not a sine. It is not an angle. It's not a bisector. It's what do we call it going from across here? What is that line called? What? Close. Just over the D. Diagonals. Okay. Look back at your little rules. What do we know about diagonals? Some of you guys already spouted out the words here. Diagonals do what to one another in parallelograms? They do bisect. So they cut in half. So I know that MQ is bisected by NR. So I know that this is cut in half and that's cut in half. So what is the value of W? It is 12. Good. Why didn't anyone say this earlier? We've been done a long time ago. You guys said that. So it's 12 because it's cut in half. And we could also use this to figure out what the whole segment is if we needed to know what MQ was. All right. Well, we know W is 12 by Alexia's reasoning. Blah, 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 blah. But we got that. All right. Part B. Are NR and MQ congruent? Well, let me highlight those so we can see what we're looking at.
I got a question.
Okay, let me highlight real quick and ask your question away.
Alright, so
Go. That technically would be W again too, but since they're the same, because they're the same, if they were the same variable, they'd be the same answer. So that would also be a W if I had to put a label on it, because they're the same value. So are those two lines congruent? That green line and the purple line, are those congruent?
yes.
Correct answer is no.
Oh, darn it.
There is going to be no. They're not congruent. Now the reason why is, now if we do their values, we don't have enough information right here. Again, we can't always judge based off a picture here. But I know this value is not. We are going to come across to a parallelogram where they are congruent.
Well, here it says the diagonal of the parallelogram separates the parallelogram into two equal triangles.
Congruent triangles, correct. I'm asking, are these segments congruent? Not the triangles.
Don't they have to be to make those?
No. No. No.
Because the tops of like Q and F, like the tops are longer apart.
What does it say? Say Q and F what? Okay. Again, we can't always judge by a picture. If we had another value, this would be different. There is a shape that we're going to go over that they are congruent. Possibly. I don't want to ruin the surprise for you guys. Circle is not a parallelogram. Is it? I don't know. We'll move further on down there. Don't want to ruin the surprise for you. All right. So now, this comes to Adriana's question here a second ago. It says, name two congruent triangles. Name two congruent triangles. I will help you with this because based off a diagonal, what Adriana was saying is a diagonal cuts into two congruent triangles. So I'm just going to look at one of these triangles. I'll say this diagonal QM. I'll say this. I'm going to name that triangle. We're going to figure out the other one that's congruent to it. So I say triangle. I'm going to name it MNQ. That is congruent to what other triangle? Now, here's a really nice thing about, oh, you got it, Aaron? What do you got? You did say it correctly. She said triangle QRM, right? M? What's that? QRM, M. All right? Now, here's one thing that's really nice with these. And it's right here. QRM. When I'm naming these things in parallelograms, all you do is look at the opposite angles, and it's a real easy name. What's the opposite angle of M? Q. What's the opposite angle of N? R. What's the opposite angle of Q? M. See how easy to name those? So name one, just look at its opposite angles. Yes? That's not always the case. Just look at the opposites. Depends how it's named. If I named it in the middle, it wouldn't always flip the one in the end. Yes? Oh my goodness. Fill out. Is there, let me see. Is it over there? Plunger over there? All right. It is recorded. All right. The last thing here, name two supplementary angles. Again, supplementary angles and parallelograms are always, they are 180. This is supplementary means very good. But they're the angles that are where? Where are they located at? Next to each other. So I'm going to pick one angle, and you guys just have to pick another angle that's beside it. This is kind of difficult the first time we do it, so make sure you're watching here. So I'm going to say that angle MNQ and what other angle would be supplementary to one another? Okay, really, I want you to focus on that middle point where that angle is. What is that middle point? What's the middle point of that angle? The middle point is N. I need to find an angle that is sitting right beside N. There's actually two choices. M and Q. Not NQ, I just want the angle. This is angle right here, angle N, angle Q. So this angle is sitting right beside it. There's also another one that's sitting beside N. Not L, it's on the outside of it. Not R, that's not right beside it. It's over here. M. So these are the two angles that are side by side, M and Q. They're the ones that are right next to it. See how they're right next to each other? They're on the same line, right next to each other, on the same line up top. So I just have to name one of those angles now. And this one, order doesn't matter, but I need that M or that Q to be in the middle. Lexia, yes?
Wait, why can you use the angle N instead of MN?
Good question. Why can't I call it angle N? Because there's that diagonal. If that diagonal was not there, you could call it angle N. I don't know what angle N is. Could angle N be right here, this little piece right there? Could it be this other piece over here? Could it be the whole thing right here? Could it be this angle back there? I don't know. So anytime you have something else, if it was just a single angle, like if I had a figure like this, and again, pretend it's a parallelogram, I could, if there's no diagonal, I could call it angle N. Because there's nothing cutting it in half. Or cutting it at any point in time. Might not necessarily be half. So I said M and Q. Can someone name me another angle with 3 points that's beside there? Either has M in the middle or Q in the middle. Someone other than Alexia. Someone other than, who else would raise their hand? Yes, Kyle, thank you. Yes, you did it. So give me 3 points that has one of those blue ones in the middle. It's on the outside of the parallelogram. NQR, like it. NQR, fantastic. NQR. And you also could have called it RQN, and we could have went the other way and said NMR or RMN. Doesn't matter. But they are the ones that have to be side by side. Questions on those? Okay. Next one.
Return of proof. Oh, there they are back again. Take what we did with previous units and apply them to new ones. Go ahead and make your 2 columns. We have our statement and our reason. Okay.
I just think it's one like
I'll show it for you.
When filling out a proof, what we're trying to prove is that they're in the opposite sides of parallelograms are congruent. That's what we're trying to prove. So when filling out a proof, what is our first reason every single time? Given. Alright? What's our first statement? What we're given.
Parallelogram.
So parallelogram, I like to abbreviate it with parallel lines, ogram. A, B, C, D. With diagonal BD. Okay, what's our last statement going to be? What's our last statement going to go over? Yeah, AB is going to CD, and BC is going to begin. What we're trying to prove. We just don't know what number it is. What else do we need to do? We normally are given it when we're doing proofs and we can mark on it and do things like that, but what were we not given this time around? A picture. So what do we need to do if we're not given a picture? Draw it. So draw yourself a parallelogram. Put 2 lines that aren't quite in line with each other. And connect. Parallel. And we know it's A, B, C, D. A, B, C, And we know we have the diagonal BD, so we have this line connecting those two endpoints.
Oh, kill it. That's a massive one. No, I want to swear.
Alright, back up here. No more fighting. Okay, it's fine. Okay, if we look here, come here, please. Thank you. What do we know about parallelograms? And their sides. But their opposite sides are parallel. That's a known fact. By definition, we know that these opposite sides are parallel. Well, when doing a proof, what did we say one of our reasons is every single time when we have parallel lines? You're on the right track? Shane? Yeah, we know we're going to have alternate interior angles every single time. Parallel lines, alternate interior angles. Okay?
Wait, do you feel like definition of or just
Ulterior angle is to put congruent, technically. We know they're congruent. If we look, that's essentially what we're doing with these proofs. What kind of two shapes were formed from that diagonal? A triangle. So essentially what we're trying to do is prove that these two triangles are congruent. So then we can say that their parts are congruent. So what type of triangles are those? If you look at the diagram. See? Yeah, they're shared sides. They're sharing this side right here. And what did we say our reason was every time we have shared side triangles? What is it? Yeah, reflexive property. So we know one of our reasons is going to be the reflexive property. Okay? Well, let's start marking things. I'll name the first alternate interior angle. I'm going to say that guy right there. So angle ABD. It's congruent to what's its alternate interior angle? Yeah, CD. Well, are there any other alternate interior angles? What's another one? CDD, this angle right here. It's congruent to, what's its alternate interior angle? From CBD, its alternate interior angle would be? Close. A. B. Okay. And then our alternate interior angles. What about the reflexive property? What side are they sharing? Yeah, BD. So when we have to write it, we would say BD is congruent to DB. It's congruent to itself, but it's flipped in those triangles. So when the triangles are flipped, you have to flip that shared side. Okay? Well, do we all have our three pieces to say that these triangles are congruent? What three pieces do we have? What is it? I heard someone say it. Angle, side, angle. We have an angle, we have a side, we have an angle. So we can say that these two triangles are congruent. Side, angle, side, angle. To name those triangles, it's really easy. You just pick one of these steps. And instead of writing an angle symbol, you just write a triangle symbol. So we pick this top one. We just say triangle ABD is congruent to triangle CBD. What did we say if we name that two triangles are congruent? What's our reason when we say their parts are congruent? Because once you name the triangles are congruent, you can state that their parts are congruent. And then we're done. So essentially when you have these quadrilateral proofs, all you're doing is you're just stating that two triangles are congruent, and then if it asks you to do so, you have to state which parts are congruent using CP, So it's really exactly like what we did in Unit 2. You just might be using some of those parallelogram properties to help you get where you're at. Questions over that? Okay. We'll finish up